Okay, so today, again, we're going to be picking up where we left off. So we're still doing a couple of same things as we were doing the other day, lateral area, surface area, and we're going to go back to a couple problems involving volume, because again, today I was supposed to focus a little bit on composite figures. So I made a few adjustments to the notes from Friday, but again, all the same figures are still there. They might just be in slightly different places. So if you are using the same notes that maybe you may have printed out from the other day, again, all the figures are still there. I just took some of the ones from early on that I said I was going to do today and put them in a separate slide by themselves. So again, you don't have to go reprint anything or anything like that. Just make sure you flip back and find the correct figure. All right, again, our test is now fast approaching. It's not the end of this week, it's the end of next week. This Wednesday, I do not have it on the calendar yet. I did not add it, but I think on Wednesday, I might add in a small quiz that I'll post on Edsby, a few questions, because we've only had one quiz since starting this e-learning process. I want to make sure we have at least 2 or 3 of them so that one grade isn't weighted too much. So on Wednesday, we'll be doing another quiz that will be posted on Edsby. It'll be just on the surface area, lateral area, and volume equations that we've been using the last 2 weeks now. I do need to make a correction. So let me go ahead and start the video. I already hit record. Okay. Never mind. It's already recording. So for we already know that. Again, those are things not on the test. There we are. So again, these are the same things that we're focusing on from the other week. So same exact formulas. However, I did make one mistake when doing the formulas. Hopefully everybody saw my message that I had posted on Edsby on Friday. When I was going back over this, I realized that I had made a mistake, and it was with this formula right here. Now, it's correct on this sheet. That wasn't the mistake. The mistake is actually in the notes that we had done. So there was this problem. It was for finding the lateral area and surface area of a pyramid, and we've done work for it. Now, if you look at your work is slightly different, because you'll notice that where I have 1/2 PL, originally I made a mistake there, and instead of using the slant height, I used the height of the pyramid. So I put a capital H instead of the cursive L. So you do need to know that, again, you're going to be using the slant height anytime you do lateral area or surface area for a pyramid, not the height. So that was one typo. Again, you might need to go back and correct it. But again, I corrected it in all the notes that have been posted. So if you are unsure, just go back through and look at the notes from Friday. The correct version is posted right now. All right, so now we're going to start off with our lateral area and surface area of a cone, which also uses our slant height. So very important here. We have base area, lateral area, and surface area formulas that we're going to use for this cone. And since our base area is a circle, we're just using the formula for a circle, which is pi r squared. And you'll always use that formula for area of the base when talking about a cone. So now, on lateral area for this one, you can actually use the formula for a pyramid's lateral area and then replace a couple of things. So instead of using perimeter, you'd use circumference, but it does simplify into an equation that is just pi r L. So again, we're not going to go through the process of simplifying it. I'm just showing you what the final equation is. Again, it's pi r L. For the entire surface area, you'd have to add the base area and the lateral area together. So you could say B plus LA, or you could plug in the formulas for area of a circle and the formula for the lateral area, R, and lateral area was pi RL. So now, using these equations. I do have two different figures here, but again, we can do them the exact same way. Notice one of them gives us the height, one of them gives us the slant height. Now, for this equation, do we need the height? No. So, in fact, on this problem, you're given information on this first diagram that we can't use this in our equation. We have to find the slant height first. So this is another one where you could use Pythagorean theorem. And when you set this up for Pythagorean theorem, we don't know our c value here, so we would have, let's see, c squared equals a squared plus b squared. Now, we don't know the c value. The 15 could be our a value. The 6 could be our b value. And we could solve this. So we have 15 squared is 225. We have 6 squared is 36. Add them together, 225 plus 36 is 261. And this one doesn't come out to a whole number when we take the square root, because again, we got to square root it to get rid of the square. It comes out to 3 radical 29. Or if you did decimal, that's fine too. But we have this side now, and that is going to be our slant height. So again, that's our L. This 6 up here was our radius. This 15 is our height. So for this one, plug the values in. Area of the base, pi r, which is 6 squared. That's 36 pi. Then for the lateral area, pi r, which again was 6. L was r, 3 times the square root of 29. So multiply that out. Well, all there is to multiply is actually the 3 and the 6, so that's 18. 18 square root of 29 pi. Both of these answers are in units squared, so this is centimeters squared. This is also centimeters squared. But we can leave the pi in there in both these cases. This is in terms of pi. On the second worksheet that I posted this morning, again, I'm asking you to leave answers in terms of pi on that one. So you have to pay attention to rounding directions. I may say either leave in terms of pi or use 3.14. But again, on the one that I'm posting today, I said to use terms of pi. So then surface area, again, we can simply add these. Since we already found the area of the base, we already found the lateral area, we're just adding those two together. So 36 pi plus 18 radical 29 pi. These are actually not like terms, so we could just leave our answer like that. If you wanted to simplify it, you could, but this is actually a good final answer. And we won't have to do any more work past that. The other one is a little bit easier because the slant height is given to us. So we don't need the height of the cone. The radius we don't have, but it's going to be half of the diameter. They gave us the diameter was 5. So the radius is 2.5. We can go ahead and plug in right away. So we have pi 2.5, oops, 2.5 squared. A little lag there. 2.5 squared is 6.25. Yep. So now that would be good for the base area. Then for our lateral area, again, pi RL. So pi R L, which L is 6. So 6 times 2.5 is 15. So we get 15 pi. So then surface area, we can add these together. Now, since we don't have a radical on either of these this time, and we only have pi at the end, these two can be considered like terms. So we could go ahead and add those values in front of pi together, and you'd have 21.25 pi. And that'd be a good answer in terms of pi. And all of these were in square feet because they're all area, and the units on this problem were feet. So again, all of these are in feet squared. All right, any questions so far before I move on to the next slide? Don't see any. Okay, I'm going to keep going then. All right, so now we have a sphere and a hemisphere. Now, I'm only asking for surface area on this, but let's go over a couple things because both of these have surface area. A hemisphere also has lateral area. So for the sphere, our surface area formula is going to be 4 pi r squared. For this one over here, we can actually do base area, lateral area, and surface area. The thing about a hemisphere that gets a little bit tricky is the fact that you actually do have a base. The base of this is a circle. So you can do the base area as pi r squared. The lateral area, a lot of people would be like, oh, well, that's going to be half of the equation for the sphere. But it's not half the equation for the sphere. The lateral area is actually 3 pi r squared. Because if you took the sphere's surface area and looked at just the top part of this sphere, yeah, we're going to cut off the bottom and we no longer have that bottom part of the sphere. So we could reduce this equation by half and you'd have 2 pi r. Oh, sorry, I misspoke here. I was doing surface area instead of lateral area. This part is 2 pi rl. So that's the lateral area by itself. The surface area then is the 3 pi r squared. Again, what I was trying to explain there though was the sphere doesn't have a base. The hemisphere does. And the equations that we're using here of pi r squared, that's the area of a circle. So for our hemisphere, we have to make sure we add back that base when we're doing our surface area. If we don't add back that base, the only thing that we're actually finding is the lateral area of that circle. So, or the hemisphere. Again, the hemisphere's lateral area will be half of the surface area of a sphere, but the surface area of a hemisphere, you have to add back on that base. So it's actually giving you that extra circle. So now it's 3 pi r squared. All right. Let's go ahead and plug these in. So these ones are just plugging in to get values. Again, for our surface area on this one, plug in the radius of 14. So 4 pi 14 squared. So 14 squared is 196. So we have 4 pi times 196. Multiply that 196 by 4. And we get 784 pi, and this is in centimeters squared. On the other one, now again, I only asked for surface area on this one, so we're just using that final formula of 3 pi r squared. So surface area, we have 3 pi. The radius on this one, we have to do half of 9, so that's 4.5. So we do 4.5 squared, gives us 20.25. Times that by 3 gives us 60.75 pi, and that's our surface area of this sphere. Now again, I should include units as well, so this is in feet squared. All right, any questions before I move on from here? Because after this part, it's all composite figures. All right, moving on. So find the surface area and volume of this figure. So this was one of the shapes that appeared earlier on in the notes. So if you had printed the notes off on Friday, you will see this image on a page much earlier. So if you want to flip back to that and do the notes on there, that's fine. But again, this is actually a composite figure. And we said it's a composite figure because you can split it up so that it's two separate prisms that are attached. Or you can look at it as one prism with a base, where the base area is that pentagon, and that base of that pentagon is going to be, you could split it up two ways, either as a rectangle and two triangles, or as two trapezoids. I'm going to do it as, if I just go from here straight across, I have a rectangle and a triangle on top. So for the base area on this one, this is the one that's a little bit tricky. Because for the base area, it is the area of the triangle and the area of the rectangle together. So I got to do 1/2 base times height. This part's for the triangle. I'm gonna write triangle above it. Plus base times height for the rectangle. So plugging those in, the entire area of the base, we're going to find by plugging in those two formulas. So for the rectangle, sorry, let's do triangle since I listed that first. For the triangle, this piece is our base, which is the same as on the bottom. So this piece is a total of 8. So I have 1/2 8 times the height. Well, the whole height here was 7. This piece was 4, so this piece will just be 3. So times 3. Then for the rectangle, that's an 8 by 4 rectangle. So 8 times 4. So for the triangle, 1/2 the base times height, that's 4. 4 times 3 is 12. 12 is the area for the triangle part. 4 times 8 is 32. That's the area of the rectangle. Add those together. 12 and 32 gives us 44. And that's the entire base area of this. So again, that's in feet squared. If you don't know those markings there, that's how you mark feet. That's shorthand for feet. So that's 44 feet squared. Now that we have the base area, they have asked us to do two different things. They want us to find the surface area and the volume of this figure. Well, again, you can use a couple different equations here. First, let's do surface area. And I'm going to do the entire equation for surface area, which was 2 times base area plus our lateral area, which can be substituted with the perimeter of the base times the height. So I'm going to use it in that format because I have pretty much all the information I need to use that one. For the volume is simply base area times the height. So let's identify what we already have. We already found the base area. This was big B. And we already got that. We already have the height. Now, which one of those numbers is actually the height? Is it the 7? Is that the height of the prism? No. The height of the prism is going to be the 10. Because again, the two bases are the pentagon that's on the front and the pentagon that would be on the back. So this 10 is the height of the solid. That's the distance between the two bases, the perpendicular distance between the two bases. The only thing that we don't have is P. So we need to find perimeter of the base. So we have to go all the way around the base. So we'd have 8 plus 4 plus 4 plus 5 plus 5. So that's 8, 4, and 4 is 16. Add another 10 to that, that's 26. So our perimeter of the base is 26. Now, we have all the things we need to plug into that equation. So surface area, I'm doing 2 times. We found the base area was 44. We found the perimeter was 26. And we found the height was 10. So we have 88 plus 260 gives us a total of 348. Again, this is surface area, so it's still in square units. For the volume, base area times height, again, we have our base area. We found that earlier, was 44. The height of the solid was the 10. So the volume is 440, and this would be in feet cubed. So those are our two answers. All right. Any questions before I move on to another problem? So now, the way I did this one, and we treated the base as that one shape. So we did the composite image for our base, and that was the area. Once we did that, then we treated everything as just one big prism. You won't always be able to do that with composite figures. So here, there's two completely separate shapes, a large cylinder and a small cylinder cut out of it. So again, if you wanted to just picture what this image could look like, now these dimensions are way big for this, but like a roll of toilet paper or a roll of paper towels, again, you have a cylinder with another cylinder missing. Well, the same thing is happening here. We're trying to find the surface area of this shape. Now, surface area and volume. The volume of this one is the easier part. So let's go ahead and first do our base area for each of these. Let's write down some equations. We have base area can be found by pi r squared. Our surface area formula, actually let's do lateral area first. Lateral area formula for this is the circumference times the height. So that's 2 pi r for circumference times the height of the solid. And then the surface area is normally pi, well, actually, are we really going to need to use surface area formula on this one? And the answer is no. And that's because there's a piece missing. So we're not going to be able to just really do surface area by itself. So even though it's asking for surface area, the surface area formula won't help us very much on this problem. The other formula that we do need to know though is volume. So volume equals base area times height. So for all these equations, we really need a couple of things: our radius, our base area, and our height. Well, again, we got to do this for two different shapes. So let's figure out the base area first. So I'm going to do base area of the small one, which would be pi. The radius of the small image is 12. So that's 144 pi. And I am leaving everything in terms of pi as I'm doing this problem. The big one. So we now have the base area of the big cylinder, again, pi r squared. The radius of the big cylinder is 24. 24 squared. And 24 squared is 576. Now, for the, let's do volume. I'm going to do volume first because that's going to be the easiest one to do. If I do volume of the small, we're just taking big B times H. Well, big B for the small one was the 144. And then H was 10. So the volume of the small one, 1,440 pi. For the volume of the big one, same idea. You have the 576 pi times the height is still 10. So that's 5,760 pi. So the volume of the overall shape, it's supposed to be a V, just subtract them. 5,760 pi minus 1,440 pi. These are like terms. They're both in terms of pi. So we're just subtracting the numbers. So 5,760 minus 1,440 gives us 4,320 pi. Now, this was one of the things that I was trying to actually find, so I'm going to go ahead and put my units on this as well. Everything was done in feet, and volume is in cubic units. So that was the easier of the two. The other part, the surface area, is a little bit harder on this one because we have to think about what parts are missing, what's been taken away, and what's being added. So first, let's go ahead and do the surface area by looking at, you're missing the circle that's on top of the smaller shape. So when we're looking at the base area for this one, we have two base areas that are a circle with another circle cut out. So we need to subtract off that area that's missing. So if we're just looking at the bottom part, so I'm going to put base, and we're doing base of the entire thing here now. So we have the big base and the little base. We need to subtract those to find the base area of each of these. So 576 pi minus the 144 pi. And if we do 576 minus 144, that gives us 432 pi. Now, that's only the area, so I can shade it here. That's only this area going around. All right, and we have that on both the top and bottom. For the lateral area, there's actually a lot of extra lateral area here. Normally, if we're doing lateral area, we do 2 pi RH, which we're still going to do that. But the lateral area here, we have lateral area of the big cylinder and a lateral area for the little cylinder. So we have to do it for both. So I'm going to do the inside one first. So now, lateral area of the small one, you have 2 pi r, so the radius was 12, times the height, which is 10. So 2 times 12 is 24. 24 times 10 is 240. So it's 240 pi. Lateral area of the big one, again, plug it into our formula, 2 pi. The radius was 24, so 24 times the height of 10. 2 times 24 is 48. 48 times 10 is 480 pi. So now, lateral area of the entire shape, because you have the inside and the outside lateral area, you have to add those together. So you have the 240 pi plus the 480 pi gives us 720 pi. So I have, this is the complete base area of the shape. This is all the lateral area of the shape. So for surface area, if I go with a basic equation for surface area, I can still get away with using it. So I have 2 times the base area plus the lateral area. Again, you just have to understand what you are doing in order to get the base area. You had to subtract the 2 areas of the 2 bases, the big circle and little circle. And for the lateral area, you had to include the lateral area of the big one and the lateral area of the small one. Now we can go ahead and plug into this equation. So 2 times the area of the base, which was the 432 pi. The lateral area was the 720 pi. So we have 2 times 432, which gives us 864. add those two together. And the surface area on this one is 1,584. And again, this is in terms of pi, and it's in feet squared. All right. Let's see. Yeah, okay, so to answer one of the questions in here, it said it was about circumference. Again, circumference is 2 pi r, so you can say 2 times pi times r, or 2 times 3.14 times r. The other question was about 61 on the assignment. I'll have to click over to that in a minute. I'm not sure what that one was on. Okay. Do I want to do all these? How much time have we spent? Okay. We won't have a lot of composite figures on this next thing. And the ones that I have on here now are a little bit easier. Let's go ahead and let's just do this one. All right. And then I'll take a look at the problem that you had asked me about the homework. So let's just do the cone with the hemisphere on top. So again, this one says the figure below is a cone topped with a hemisphere. Calculate the total surface area if the radius of the cone and hemisphere is 10 centimeters and the height of the cone is 24. So let's go ahead and draw on here those two values. So this is 10 and this is 24. So they wanted the surface area. So for a sphere or hemisphere, yeah, remember it is 3 pi r squared. So that's for the hemisphere. Then we're gonna have to add to that the surface area of the cone. But now wait a minute. The surface area on this, is it really gonna be the entire surface area of both those shapes, or what's missing? What's missing on this? What should we not include in both those shapes? I don't know if anybody's trying to answer it, but all right. What's missing on both these shapes is the actual circle, the base that makes up the circle. So instead of using our surface area formulas, what should we be using? We should just be using the lateral area because the base of each figure is missing. So we're going to actually just use the lateral area formula for both of these. So let me replace that 3 with the 2. Because this part is the lateral area of a hemisphere. Whereas on the second half of this, I only need the lateral area of a cone because we don't have the bases on the outside. So this is the formula we're going to use to find the surface area of this figure. We need to plug in the pieces that we need. So we have 2 pi, the radius is 10 squared, plus pi times the radius is 10 times the slant height. Is that 24? No, it's not 24. This is another one of those problems where we have to do Pythagorean theorem because we need the slant height out here. But again, in order to save time, you don't really have to do Pythagorean theorem. This is one of our triples. 5, 12, 13. It's just been doubled. Again, I'm not going to show Pythagorean theorem every single time I do a problem like this because if you know your triples, you shouldn't have to. So 26 goes in. So now multiply this out. 10 squared is 100 times 2 is 200. So 200 pi. 2 times 6 is 12. 12 times 10 is 120 pi. Add those two together. That's 320 pi. Now this was all in centimeters, so we can write centimeters squared. And that would be our surface area in terms of pi. Oh. Sorry. Thank you. Thank you for that, Alex. You caught it. My dots weren't very clear when I wrote, and I read it wrong. Helps if you can read your own handwriting. Thank you. Let's erase that part and this part. So let's try this again so we can actually read my handwriting. So this was 10 times 26. Not the way I read it. I read it as 10 times 2 times 6. So 10 times 26 is 260. Add those together, and we should have 460. Thank you, Alex. All right. Okay. Let's keep going. And that, I don't like that 4. That 4 looks more like a 9 than a 4. Just make sure you know that's a 4, not a 9. All right. Let's go take a look. So again, on the assignments, this was one of the 2 assignments. This was the one that was on the end of the notes on Friday. So if you've already started on this one, great. If not, again, it was 4 different pages of springboard problems, but I'm not having you do all of them. I'm only having you do some of them. And then for the second worksheet's actually a little bit easier. It's a little bit of a review of lateral area, surface area, and volume. So some of them are asking about lateral area and surface area, and some are asking about volume. Now, Alex, you said that you needed help on number 61. So let's go back. 61. All right, so it's that one. Let me close this panel and I'll bring it up so it's easier to read. So let me close this. I'm gonna pause. Actually, I'm just gonna share a different screen. Share this one. So now. All right, find that worksheet. All right, here we are. So you said number 61, correct? So on this one, there's a couple different questions about it. It says a net first cylinder is shown below. The diameter of each base and the height of the cylinder are 6 centimeters. Find each measure to the nearest tenth. So it told us the height. So this goes back to the image of what I'd shown you guys on Friday. This is just the net of that figure. So one of the first things that we had done in the notes was the net. I'm going to go ahead and draw on here and show what this would look like. So if I was to draw this as a cylinder, standing upright, there's my cylinder. They said that the diameter of each base is 6. So that's the distance all the way across is 6. The radius would then be 3 because it's going to be half of that. And it said that the height is also 6. So all of these are in centimeters. So picture it as our actual shape there. It first said find the circumference of each circle in the net. Well, circumference of each circle has to be the same. So you'd be doing 2 pi r. Let me scoot this up a little bit. I'm just going to throw it over here so that you can see it. All right, so for each one of these, again, different formulas, but circumference, we've done circumference formula before. C equals 2 pi r. And in this case, the radius was 3. So 2 pi times 3, which would be 6 pi. I'm going to leave it there in terms of pi. What are the dimensions of the rectangular part of the net? Or let me just make sure that we don't have to. Yeah, it doesn't say anything about using 3.14, so I'm not going to. I'm just going to use terms of pi. What are the dimensions of the regular rectangular part of the net? So the rectangular part of the net is made up of, again, that shape that's up there. This part here is the same as the circumference of the circle, because this has to wrap around that bottom piece. So dimension here is 6 pi, and the height which they gave us was 6. So the dimensions are 6 pi and 6. Again, if you want to put centimeters on each one of those, because we are 2 dimensions. In the net, find the area of each circle and the area of the rectangular part. So again, those circles, those are our base parts. We're finding the base area here. So for the circle, I'm just going to go ahead and use big B because that's actually our base area there. So area of the base is pi r squared because it's the circle. Pi r squared. Plug it in. The radius again is 3. So that's 9 pi. The area of the rectangle, well, the rectangle is our lateral area. So again, you can either look at it as a rectangle and use the 2 dimensions that we have here because we found the circumference already. I'm going to do it as we do the actual equation, right? Lateral area, if that's what we're actually finding here, is the circumference and the, oops, sorry, circumference times the height. I don't know what I was doing there. Hold on. Circumference times the height, not plus the height. Again, we already found circumference, so normally I would plug in 2 pi r here, but again, don't need to since we already found that up here. So the circumference is 6 pi. The height is 6. So the lateral area is 36 pi. So the rectangle is the lateral area, and the circle is that base area there. All right. What is the surface area of the cylinder? Well, surface area of the cylinder is found by doing surface area equals 2 times the base area plus the lateral area, which is what we just found. We just found the base area and the lateral area. So 2 times 9 pi plus the lateral area was a 36 pi. 2 times 9 is 18. So we have 18 pi and 36 pi. And if we add those together, 18 and 36 gives us 54 pi. Again, this is also in centimeters. So if we wanted to, we could put centimeters squared. All these are in centimeters, so centimeters squared, centimeters squared. And that would be that problem. So again, I didn't do a problem exactly like that in the notes, but it is based on everything that we talked about in the notes. So again, you might get questions that are asked in different ways. So this one was just being asked a little bit different, but it was still based on that same idea. Any other questions? All right, I'm gonna go ahead and end this. I know that one took me a little over time, but again, since there's a question, I want to go ahead and answer it. Now, for tomorrow, all right, tomorrow on Tuesday, normally I hold office hours from 12:45 to 2:15. I am not going to be holding those office hours tomorrow. Tomorrow is the day that they're giving math teachers to go clean out rooms. So they have each department going at different times to clean up their rooms and stuff. So tomorrow I won't be on at all. So if you don't get a response from me, it's because I'm going to be at school for a good chunk of the day, cleaning up my room. If you do have questions, again, by all means, send them to me. I might respond, but I just won't be as fast coming around since, again, I won't be on as much tomorrow since I'll be at school for a good chunk of the day. But again, I'll still have my office hours on Thursday. On Wednesday, there will be a short lesson on density. If you have any other questions, you can ask me some questions during that time as well. And then I will be posting a quiz later in the day on Wednesday that I'll leave open for a couple days at least. All right. Any other questions? No? All right. Well, then I'm going to stop this meeting. I hope you guys understood everything. Have a good day.